Hello everyone, let's have an overview of Bayes' rule. Bayes' rule or Bayes' theorem is a cornerstone of probability theory and statistics. It tells us how to update our belief in hypotheses when a new data or evidence becomes available. So in simple words, you have initial belief of something, you have a hypothesis, initial hypothesis, and you want to validate that hypothesis. You got a new data, you made an experiment, and you want to see, based on that new data, is your hypothesis correct or not, or there's something else? So this is, in simple words, what is Bayes' rule about. So formally, Bayes' rule is often stated as the probability of hypothesis given data. So you want to measure the probability of the hypothesis, the change of the probability of your initial hypothesis based on a new data you got, equal to the probability of that data if your hypothesis were true. Okay, given your hypothesis, multiplied by the probability of your hypothesis. This is your initial belief, divided by the probability of the data. This is the evidence you got, and it's marginal likelihood. That means it gets all the possible outcomes in it, whether it agrees with your hypothesis or doesn't agree with your hypothesis. So let's talk about it again, where P hypothesis given data is the posterior. This is what you want to calculate. You want to see the change of the probability of your initial hypothesis based on the new data or an experiment you have made. Now, to do that, you need to calculate the likelihood, which means the probability of getting that data in the first place based on your initial hypothesis. And also you need to have your probability of your initial hypothesis, and you need to have the marginal likelihood, which is the probability of the data or the evidence. This is the total probability of observing the data under all possible hypotheses. So let me give you an example. So here's again the formula, and let me give you an example to how to use it. Suppose you wish to determine if a coin is fair, meaning heads and tails have equal probability. You believe initially before any flips that the chance the coin is fair is 0.66 and that it's not fair is 0.34. You flip the coin 5 times and all 5 flips comes up heads. Using Bayes' rule, what would you estimate to be the probability that the coin is fair given these data? Now let me clarify some stuff before we start. So we have a coin. We have two choices. This coin is fair or not fair. Okay? If it's fair, that means if you got head or tail, the chance to get a head is 50% and the chance to get a tail is 50% because it's fair. You have initial belief, you have initial hypothesis, says that the coin is fair by 6.66%. Type. And so the unfairness will be 0.34%. That means 1 minus 0.66. So to prove this, to validate your hypothesis, you have to do an experiment. So you decided to flip the coin 5 times to see the data, and based on that data and using Bayes' rule, you want to see if your hypothesis is true or not. So let's start the calculations. So as we know, if the coin is fair, that means we have 50% chance to get whether heads or tails. If it's not fair, here comes the problem. That means there is a bias from that 50% we talked about first. And to validate this, we have to do an experiment. We flip the coin 5 times. And in those 5 times, we actually got 5 heads. So now, based on that data, is the coin fair or not? And we want to calculate exactly how much based on that. So we have the probability of fairness. This is initial belief. This is given 0.66, and the probability of it's not fair is 0.34. And we want to find the posterior. That's probability. That's mean after this experiment of flipping the coin 5 times, we want to see whether our initial belief is right or wrong, and what will be better image after this experiment. So now let's estimate the likelihood if the coin is fair. It's very easy. If the coin is fair, the probability of seeing 5 heads in a row is exactly So half to the power 5. Okay, because we have 50% chance if it's fair. So every time we flip it, we will have eventually half to the power 5, and it's equal to 0.03125. Okay, so the likelihood of the coin is not fair, and here comes the problem, that if it's not fair, we don't know exactly how much the probability. So to proceed correctly, we typically need a model for how not fair behaves. A common assumption is Peter-Bernoulli framework, in which if the coin is not fair, we assume the bias P for heads is unknown, drawn from a uniform prior, meaning all biases from 0 to 1 are equally likely. It could be any value from 0 to 1. So mathematically, that means that the probability of the data, the experiment, given that the coin is not fair, is equal to the integration from 0 to 5 for b of the power 5. The result will be b to the power 6 over 6 from 0 to 1, and after substitution we'll have 1 over 6. So let's go back to the Bayes rule. Bayes rule tell you exactly that if you want to calculate whether your coin is fair based on the new data you got from the experiment, you have to multiply the probability of your data if the coin was fair, multiply the probability of the coin is fair, which is your initial belief, over the marginal likelihood, which means the probability of getting that data, whether it was fair or not fair. So we here you see the clear image. We have substituted all the numbers, and the answer was 0.27. So it's clearly that the coin kind of not fair. The probability here tells us that our initial belief is not precise or not accurate. The more accurate thing is 0.27, and the more you do the experiment, the more data you get, and the more every time you apply Bayes rule, you will get more accurate results. Thank you very much. Have a good day.